All right, here we go. I'm going to try to explain, excuse me, assignment 17 to you. Okay, so we see the problem is the square root of 49x to the fifth. So remember, the first thing we have to do is split it up. The square root of 49 and the square root of x to the fifth. We automatically take the square root of x to the fifth and rewrite it with a fractional exponent. Okay, now we know the square root of 49 is 7. So you just rewrite it as 7 and leave it. Okay, the 5 halves, you do 5 divided by 2, you get 2.5. Now you want to split up the 2.5. So an x goes with the whole number 2, and an x goes with the half. X squared stays x squared. X to the 1/2 gets rewritten as a radical. So now when we go and put these together, these two are not underneath a radical, so they get written together in front. And this is the only thing left under a radical, and so you put it afterwards. Okay, number 53. We're going to do the same thing here. We're going to split it up. So I have the 4th root of 12, 4th root of x squared, 4th root of y to the 6th, and 4th root of z to the 12th. Okay, 4th root of 12. I'm going to look at my x to the 4th paper. I do not see 12 on here. I don't see a factor of 12 on here. So that means all I can do is leave that. Can't do anything with that. Okay, the 4th root of x squared. Remember that when the power is smaller than the index, you're not going to be able to do anything with it. So we're just going to leave it. Now, this one, the power is bigger than the index, so we rewrite it as a fraction. We divide it, so you get 1.5 or 1 2/4. So the y to the first stays y, and my y to the 2/4 goes back into a radical. Now, I didn't change it to a half because this one is a fourth, which I could also change to a half, but this one I can't change to a half. This one has to stay fourth. And they all have to have the same index so I can put them back together again. Okay? Okay, my 4th root of z to the 12th, rewrite it as a fraction, divide it, you get the whole number 3, so z cubed. Okay, my y and my z cubed don't have a radical, they go in front, and the rest of these get put back together underneath the same radical. Okay, number 54 has this multiplication sign. That means we have to multiply before we do anything else. So 4 times 12 is 48. X cubed times no x is x cubed. Y to the 5th times y squared is y to the 7th. And now I'm splitting this up. So 3rd root of 48, 3rd root of x cubed, 3rd root of y to the 7th. Okay, my 3rd root of 48. I go to my 3rd root column. I do not see 48 on here. However, I can divide 48 by 8. So I'm going to break it down into its factors. The 3rd root of 8 that I got from the list times the 3rd root of 6. My 3rd root of 8 becomes 2 because it's on my list. My 3rd root of 6 stays. Okay, my index and my powers cancel out, leaving me with just x. My power is bigger than my index, so I rewrite it as the fraction. I divide them, so I get 2 1/3. So I get a y with the squared, and I get a y with the 1/3, which turns into the 3rd root of y. Put it all back together. 2x and y squared go out front. And then my 3rd root of 3rd root of 6 and my 3rd root of y go together. Okay, number 55 is the same type of problem. I have to multiply first. So x squared times x cubed is x to the 5th. Y times no y over here is just y. Z cubed times z to the 5th is z to the 8th. Split them up. Square root of z to the x to the 5th, square root of y, square root of z to the 8th. Okay, power is bigger than the index. So write it as a fraction. Divide it. 1, the whole number gets a letter. The fraction gets a letter and turns back into a radical. This one, the power is 1. The index is 2. So the power is less than the index. You have to leave it. Okay, power is bigger than the index. Divide them. You get z to the 4th. So no radicals. X squared z 4th goes out front. Square root of x, square root of y go together under the square root. Okay, number 56. You can't really do anything with this -3 and the 5th root of x to the 6th. You can't leave a radical on the bottom. So we have to turn this power of 6 into a multiple of 5. I mean, something that we can divide it by 5. Now, I can't go backwards. I can't make 6 into a 5. But I can go forwards and make 6 into a 10. I make the 6 into the 10 by multiplying by an x to the 4th. It has to be the 5th root of x to the 4th so I can actually multiply these together. What I'm doing on the bottom, I have to do on the top. So on the top, I just write these next to each other. On the bottom, I get the 5th root of x to the 10th. Now remember, what you're doing is you're taking the power over the index. So 5 over 2, over 5, sorry, 10 over 5 is 2. So now my bottom is simplified and doesn't have a radical in it. Okay, number 57. Again, you can't do anything with the x and the y because they're different. So we're going to split them up. Now, we can't leave a radical on the bottom. So I have to turn this 4 into a multiple of 3. So the closest multiple from 4 is 6. So to turn the 4 into a 6, I have to multiply it by y squared. Okay, now on my top, I went ahead and simplified this because I know my index and my power cancel out, leaving me with just x. So when I multiply the bottom by the 3rd root of y squared, I have to multiply the top by the 3rd root of y squared. So the top, you just write them next to each other. On the bottom, you get the 3rd root of y to the 6th. Now remember that 6 divided by 3 is 2, and the radical goes away. So now I don't have a radical on the bottom. Okay, number 58. I went too far. Okay, this one we're going to split up. Now there's a couple different ways to do it. This time I decided to do it like in fractions. So I took the 20 over the 9 and the x cubed over the x, and my y squared was on top and my z cubed is on the bottom. Okay, so now I took this and I simplified it. Okay, I know the square root of 9 is 3. My square root of 20 gets broken down into the square root of 4 times the square root of 5, because 4 is on my x squared list. And I want the square root of 4 because it turns into 2. So my bottom turned into 3, the top turns into 2 square root of 5. Here, I've got x cubed over x. So if you use your exponent rules, when you have the same exponent being divided, keep the exponent, subtract, or keep the base, subtract the exponents. So 3 minus 1 is 2. So now I have the square root of x squared. The power and the index cancel out, leaving you with just x. Okay, now up here, I had just the y squared. So those cancel out, leaving me with y. Here I had a 1 on top and a z cubed on the bottom. Now remember that you can't leave a radical on the bottom. So I have to turn this 3 into a multiple of 2. So the closest one is z to the 4th. So I change z cubed into z to the 4th by multiplying by square root of z. Remember, whatever you do on the bottom, you have to do on the top. So 1 times square root of z is square root of z. On the bottom, I get the square root of z to the 4th. 4 divided by 2 is 2. So this becomes the square root of z over z squared. Now, I have to put it together. This is where the things on the bottom stay in the bottom, the things on the top stay in the top. So the 3's on the bottom, the z squared's on the bottom. So that's what I have on the bottom here. Everything else goes on the top. Remember that the 2, the x, and the y go out front, and the 5 and the z go underneath the square root together. Okay, number 59. Again, what we've got is we've got the same bases being divided. So, for me, the easiest way to picture that was to change it into exponents. Okay, so I know I'm going to keep the exponent, or keep the base and subtract the exponents. So that means I'm going to end up doing 6/4 minus 5/7, which I can't do until I have common denominators. So I'm going to multiply 6/4 by 7, and I'm going to multiply 5/7 by 4. So this is what I end up with. So 42/28 minus 20/28 gives me 22/28. And remember, you always want to simplify the fraction. Now that we're down to just a base and an exponent, simplify the fraction. So divide them both by 2, and I get 11/14. Turn it back into a radical. Okay, that was it. Hopefully that answers some of your questions. If not, get a hold of me so we can make sure you know what you're doing, okay?